Hello everyone, this is the worksheet on organizing quantitative data. So we are going to go through some of these questions on how to create a frequency table for quantitative data, that means numerical data. And this worksheet will cover the different types of frequency tables that we have learned about, right? So it says here for question number 1, for the data set given below, use the specified grouping method. The U.S. Census Bureau conducts nationwide surveys on characteristics of U.S. households. Following are the data on the number of people per household for a sample of 40 households. Use single value grouping. Now keep in mind that we said previously we can use single value grouping when we work with a limited range of values. Not necessarily a limited number of values, but a limited range of values. That means that the difference, that means the difference between the lowest value and the highest value in the data set is limited. All right. So here the lowest value is a 1 and the highest value is a 7. All right. So that's a narrow limit. So we can go ahead and use the single value grouping to create the frequency table. Now, in the first column, I've given you the table here. The first column is listing the number of people per household. So we can list each unique value in the data set in one row at a time. All right, so we have a 1. So I'm going to write 1 in the first column. And then we have 2, 3, 4, 5, 6, 7. So all the values between 1 and 7 are in the data set. So 1, 2, 3, 4, 5, 6, 7. So I'm going to write each unique value in the data set, 1 per row. Now in the next column, we have to tally. We have to find out how many 1s there are in this table, how many 2s there are in the table, and so on. And like I said before, we are going to go one value at a time. All right. And as you go along, make sure you cancel it out so that you don't end up double counting. So the first value, I'm going to go column by column. So the first value in the table here is a 2. So I cross that out and put a straight line in the row for 2 under the tally column. Next one is a 1. I'm putting a 1 here. Then we have a 7. Let's go down to 7 and put a 1 here. So let me make sure I cross the 7 out. Then we have a 6. Here's a 6. And then we have a 2. So I'm going to put a straight line in the row for the 2. And then I have a 5. So let's go to 5. What else do I have? I have a 4. So 4. And then a 1, 1, 5, 5, 1, 1, 2, 2, 4, 4, 2, 2. And then I have another 2, but now I have 4 2s, 4 lines for the 2 already. So this is the 5th one. I'm going to put a line across the 4 to make it a bundle so I can count by 5s. All right, so then I have a 3. Let's continue this. Then I have a 1. Then I have a 2. Another 2. A 5. 3. And then a 1. Okay, so now I can bundle my 1 across, then start a new bundle for 1, and then I have a 3 and a 1 and a 2, a 2, a 4, 4, 3, 2, 3, 3, 2, 2, 3, 4, 3, 2, 5, and the last one is a 3. All right, so let's see. Now we have completed our tally. Now we'll go and count the numbers and write in the frequency columns. All right, so 5 plus 2, 7 for number of people of 2. All right, it's 5, 10 plus 3, 13. Then for number of people per household 3, we have 5 plus 4, 9 responses. Number of people of 4 has 5 responses. Then we have 4 for 5, so I'm writing 4, and then 1 each for 6 and 7. Now we have to sum this up, all right, the frequency values. 7 plus 13 plus 9 plus 5 plus 4 plus 1 plus 1, and we should get a sum total, which is also called n, which should be equal to 40. So please do the addition and make sure that it matches with the number of data set that was given to us, 40 households, because that will tell you that your tally was correct. All right, it can still go wrong in between. However, at least you counted all of them. All right, that's what it tells. And n refers to the total number of frequencies, also known as sample size. All right, so that's the notation for sample size. And then the last column says find the relative frequency. Again, relative frequency is a calculated value, and it goes by the formula F over N. And that's another reason we need to find N. In order to find the relative frequency, you have to divide each of these frequency numbers by whatever value N is. So 7 over 40, N is 40, right? So it's whatever the frequency is divided by 40 in this case. So 7 over 40 is 0.175. You have to use your calculator for this. So 13 divided by 40 is 0.325. 9 divided by 40 is 0.225. 0.225. 5 divided by 40 is 0.125. Then we have 4 divided by 40 is 0.100. 1 divided by 40 is 0.025. And again, 1 divided by 40 for the last one is 0.025. Now, when you sum up your relative frequency values, it should approximately add up, be very, very close to a 1. All right. And another thing I want to mention is, unless otherwise told, please have your values up to 3 decimal places. Please write your values up to 3 decimal places. All right. Don't round it up to 2 decimal places. Otherwise, you will be off by quite a bit in statistics. All right. So here we have our frequency table for question number 1. We got our tally. We got our frequency from the tally. And then we got our relative frequency using the formula F over N. Now, part B of the question says, construct a frequency histogram based on your result above. Add a title and label the axis. All right. So this time they've asked for a frequency histogram, not a relative frequency histogram. So we are going to use these values here in the frequency column to create our histogram, right? So first, I have given you the vertical and the horizontal axis. Let's scale the horizontal axis first. What do we put along the horizontal axis? The number of people, that means the values in the first column of the frequency table, which is number of people per household. And that's also going to be the label of the x-axis. So we had values from 1 to 7, correct? So the point of intersection between the x and the y-axis is marked as 0. And so from there, I'm going to kind of divide it as equally as I can by hand into 7 parts. So let's make this a little bit bigger. So 1, 2, then a 3, 4, 5, 6, and let's make 7 here. All right. Now for our y-axis, we have to look at the values in our frequency. All right. So the lowest value in our frequency is a 1 and the highest value is a 13. Right. So if we divide our if the highest mark on the y-axis is a 15, from 0 to 15, that should be able to cover all these values, right? So start from 0, and I'm going to make it intervals of 3. All right, that means I'm going to divide the y-axis into 5 equal parts. So let's make it like this: 3, 6, 9, maybe make this a little bit taller, 9, 12, and 15. All right, and this is going to be labeled frequency, and the x-axis, the horizontal axis, is going to be labeled number of people per household. All right, so number of people per household. Or you can just write it as number of people, but make sure that both axes are labeled. Now for when how many of the respondents said they had one member in their family, in their household. So that was 7, right? So we have to draw a rectangle bar going all the way up to 7. Where would we have 7? Would be a little above 6, right? Maybe somewhere here. So I'm going to draw a rectangle, go all the way. The rectangle has to be around 1, with 1 at the center of the rectangle, the center of the base of the rectangle, so to speak, and then go up until roughly 7, wherever 7 is, and then go midway between 1 and 2 and drop the rectangle bar. All right. Then for 2, how many people said 2? 13 people said 2. That means we have to go all the way up to 13. So 13 will be a little above 12, right? Or maybe make it a little bit more. Maybe here. All right. But this time, this is a histogram. So I have to make sure that it touches this rectangle bar around 2 is going to touch the right-hand side of this, the first rectangle bar. All right. So I'm going to just raise this line, go up all the way to 13, and turn around and drop the line between 2 and 3. All right. So now we have to find how many for 3. There were about 9, right? So 9 is right here. So I'm just going to, here is 9. So let's make it go up here. And I'm sorry, this is not quite a straight. These lines are not straight lines, but just drawing by hand digitally. For 4, it's, what's the frequency for 4? 5, correct? So let's go all the way to 5. So 5 would be a little bit below 6. So it goes something like this and then down. Again, make sure that the rectangles touch each other. For 5, it was 4. So a little above 3 perhaps. So let's make it like this. And for 6 and 7, it was 1 each. So maybe like this and like this. All right. So here we have our histogram, right? We have our histogram, frequency histogram, based on the table we created for the data on number of people or number of members per household. Of course, we haven't added a title, so you can write here number of people per US household. Per US household. If you want to be more precise, you can say frequency histogram for, okay, frequency histogram for number of people per US household, but number of people per US household is good enough title. All right, so this is how you create your histogram, a frequency histogram. For the relative frequency histogram, which is the next part of the question, again, you can use the same labels and the same titles. Again, divide your x-axis the same way. So we'll have here 1, 2, 3, 4, 5. Should be a little more spaced out. All right, 5, 6, and 7 roughly. All right, but this time the y-axis has to be scaled with your relative frequency value. So we have, what is the highest relative frequency in our calculations? 0.325, right? So if we go up all the way to 0.4, that should be enough to cover all these proportions, right? So I'm going to divide the y-axis as 0.1, 0.2, 0.3, and 0.4. So let's make that 0.1. So 0.1, and then 0.2, 0.3, and let's make 0.4 here. Or make it a little bit, you're kind of going outside the y-axis, which is not a good idea. All right, so I'm going to relabel the y-axis. So let's make it 0. Oops, did I just lose it? Sorry, I just lost the y-axis somehow, but I drew the line here, and let's work with this. All right, so we'll divide it as 0.1, 0.2, I'm having a tough time here. Hold on, please. Zero point two, 0.2, 0.3, and let's say 0.4 is here. All right. Okay, so now we will have to draw our relative frequency histogram. So when for 1 it was let's go back to our table. For 1 it was 0.175. So a little bit below 0.2, correct? So it'll be like this, 0.175 would be somewhere here, all right, 3/4 way between 1.1 and 0.2. So let's make it like this. And then for 2, it was 0.325. So 0.325 is going to go all the way up here. So 0.325. Come down. And then was 0.225. So 0.225 is going to be above 0.2. So maybe here. All right, and then what do we have for 4? 4 was 0.125, 0.125, right? So 0.125 would be somewhere here. Let's make it here 0.125. And then 5 was 0.1. So that's somewhere here. Okay, and the last few were 0.025. So 0.025 would be a quarter way between 0 and 0.1. All right, so maybe we'll just make it like this. Okay, so this is our relative frequency. Again, please label your axis. This is going to say number of members or number of people per household. And on your y-axis, please label the y-axis with relative frequency. That's relative frequency, not frequency this time, but relative frequency. And then a title here, number of people per US households. Per US households. All right, so this is how you're going to create a single value grouping table, a frequency table, and then draw the histograms, a frequency histogram first and then a relative frequency histogram. Question number 2 is an exercise on creating a frequency table using the limit grouping interval method. All right, so let's read the question. It says early onset dementia. P. Harris and John Keedy explored the experience and struggles of people diagnosed with dementia. A simple random sample of 21 people with early onset dementia gave the following data on age and years at diagnosis. Use limit grouping with the first class of 40 to 44 and a class width of 5. Now, they've kind of made things easy for us because they've given us the first interval that we should start with. And the class width of all the intervals should be 5. What is class width? It's the range of values that can go into a particular interval. Okay, so because they've given us the class, the first interval, we can just write the interval in the first row and continue from there. However, most often or more often, they will not give us the starting interval. They will just give us the class width. And we have to figure out by looking at the data, the lowest value in the data and the highest value in the data, and make sure that all of these values from the lowest to the highest are or can be fitted into the intervals that we create. All right, so you may want to get some practice on that, but your homework assignments will give you that practice. But this one is easy to begin with. It has the first interval as 40 to 44. So let's write that down. 40 to 44, and then it'll be 45. Now these are all integer values. We are using limit grouping. It's not cut point grouping. So we can start the next interval from the next number after 44. So 45 to 49, and then 50 to 54, 54 to 59, and then 60 to 64. Now let's just see what is the highest number or the largest number in this data set. I think 61 is the largest number. So if we have our interval from 60 to 64 as the last one, that's enough to fit all the data points in our data set. So the lowest value is a 41 and the highest value is a 61. So we got all our intervals here. Let's quickly check the width of each interval. How do we do that? We take the lower end or the lower class limit of one of the intervals and subtract the lower class limit of the previous interval. So 45 minus 40 is 5. 50 minus 45 is 5. 54 minus 50, I'm sorry, I made a mistake here. I'm glad I did that because that's a lesson. This should be 55. All right, so see, that's checking for the width helped us find a mistake. All right, so 55, so I quickly change this to 55. 55 minus 50 is 5, and 60 minus 55 is a 5. All right, so we got our class widths on the left hand side. We have to do the same on the right hand side too. So 49 minus 44 is a 5. 54 minus 59 is a 5. 59 minus 54 is 5. And 64 minus 59 is 5. So yes, we have all our intervals of the same class width of 5. Now we can go ahead and start the tallying process. Now I'm going to start it off, but then I will have you finish it up, all right? Because otherwise it will take too much time through this worksheet. So the first value is 60. I'm going to cross that out and put a mark at 60. The next value is 61. I'm going to put a mark here. The next one is 47. Put a mark here. Then we have 58. Should go here. 54 goes here. 42 goes here. 52 goes here. Right? 59 here. 56. 58, 55, 57, 59, 53, 49, 58, 44, 41, 51, 46 and 43 goes here. All right, so I thought I would have you finish the tallying, but I ended up finishing it anyway, so not a problem. Now we will have to count the tallies and write the numbers here in the frequency column. So the first one is a 4, second one is a 3, then we have a 4, and then we have 5 plus 3, 8, and then we have a 2. All right. So now we will be calculating the relative frequency in the next column, which goes with the formula F over N. Now we will need to sum up all our frequency values and make sure that we have a N value of, what was it, 21, is it? We had 7 times 3, 21. So just add up your frequency values. 4 plus 3, 7, plus 4, 11, 19, plus 2, 21. All right, so we have all that correct. Now you have to find the relative frequencies. So 4 divided by 21, F over N. N is 21. The denominator stays the same for all the calculations, only f will change. So 4 divided by 21 is 0.190. 3 divided by 21 is 0.143. Then 4 divided by 21 again is 0.190. 8 divided by 20 is 0.381, rounded up. And 2 divided by 21 is 0.095. When you add these values up, it should approximately add up to a 1. All right, it can be 0.999 or maybe 1.001 based on how you've rounded up to the third decimal place. Again, by default, always keep your decimals to the third place. All right. So we have all our relative frequency values here calculated using the formula F over N. Very simple formula. As long as you have all your frequency values right, as long as you have the correct value for N, it shouldn't be a problem finding relative frequencies. And you can always cross-check by adding them up and making sure they add up to a 1. Now, class mark is the next column. What is class mark? Class mark is the midpoint of each interval. And that goes by the formula lower limit plus upper limit divided by 2. So 40 plus 44 is 84 divided by 2 is 42. All right, 42. 45 plus 49 divided by 2 should give us 47. Likewise, we will have 52, 57, and 62. These are the midpoints of our interval. Why do we need the midpoints of the interval? Why do we need a class mark? The main reason is if we want to find the average, if we have to calculate the average from a frequency table arranged in the interval form in class intervals, then we are going to need the class mark, the midpoint of each interval, and multiply these by f, the frequency values, and then we are going to add it up and then divide by 21. I will explain, work out a problem to find the average. All right, but this is something that is also explained in the PDF textbook on Canvas. All right, so please check for the textbook information. They are all in PDF format and they are under the textbook section in the weekly modules in Canvas. All right. So while we are at it, let's calculate the CM, the class mark times the frequency values, and write it in the last column. 42 times 4, all right, CM column times the frequency columns. So these are the values, 168, and then 47 times 3 is 141. Then the next one will be 260, which is 52. Well, not quite 260. It will be, all right, so 4 2s are 8, so 20, 208. And the next one is 57 times 8, so 8 times 7. 456, and then 62 times 2 is 124, and then we have to sum them up, and I'm going to do the summing up when we calculate the average. All right, so here we have this table now created using the limit grouping interval method. We did the tally, we found the frequency, we found the relative frequency, and also class mark. But the next question says construct a relative frequency histogram for the above, add a title and label the axis. So that's what we are going to do next. Let's go ahead and create a relative frequency histogram from the above data, from the above table, right? So let me draw a vertical axis and a horizontal axis, and I'm going to label it, the horizontal axis is going to be called ages, and let me extend this a little more. Ages at onset, and well, let me write it properly instead of using abbreviations. At onset of dementia, and this is a relative frequency histogram, relative frequency. So that's going to be the label of the y-axis. So we are going to scale our x-axis with the ages. However, the ages are in interval form. All right. So that's another reason why I created a class mark column. I'm going to use these class marks instead of the intervals. All right. However, you can also write 42, 44 for each mark on the x-axis. So let's just build this up here. How many do we have? We have 5 intervals, right? So 1, 2, 3, 4, and 5. One, two, let's make it a little, 3, 4, and 5. Okay, so we can either use our class marks here as 42, 47, 52, 57, and 62, or you can also write it as 40 to 44. We write the intervals here, that's fine too. All right, you will not be deducted points for writing in interval form or in class mark form. 50 to 54, then we have 55 to 59, and lastly it's 60 to 64, right? So either, it's fine. All right, then for the relative frequency, let's look at the relative frequency values. The highest value we have is 0.381. So if we go up to 0.4 on the y-axis, that should be enough to cover all the relative frequency values. So let's divide this into 4. So 0.1, 0.2, 0.2, 0.3, and extend this a little more, 0.4, perhaps 0.4. All right, we won't need to go up to 0.4, so let it be there. Now for 40 to 44, what value did we have? 0.190, which will be a little less than 0.2. 0.190. All right, for 45 to 49, it was 0.143. So 0.143 is halfway, kind of halfway between 0.1 to and 0.2 roughly. So let's make it here. All right, then we have for the third interval, 50 to 54, 0.190 again. So let's see, 0.190. So again, the rectangle bars should touch each other, 0.190. So same as what we have for the first interval. And then what do we have? 0.381. Oops, now this is floating around. I have to move. Just a second, let me take care of this. It was 0.190. .381 was the next one. So it would almost go up to 0.4. So let's do that. Keep it a little bit less than 0.4. All right. And then finally, the last value is 0.095. Oops. 0.095 would be a little bit less than 0.1. Maybe somewhere here. All right. So this is our histogram. We need to give a title to it. So you can say it's the proportion of age distribution. Proportion. At least that's the title I gave it. But you can also write age at onset of dementia. So proportion of age distribution. For onset of dementia. All right. So this is how you would go about creating a relative frequency histogram from the limit grouping interval that we created earlier. Now we have to create a stem and leaf plot for the same data on the onset of dementia. Now keep in mind that for the stem and leaf plot, we have to first divide each number, partition each number based on its digit. The rightmost digit, let me just get my pen out here. The rightmost digit is going to be the leaf, right? And the rest of the digits will be our stem. Now, since we are dealing with two-digit values here, the digit on the left is going to be the stem, and the one on the right is going to be our leaf, right? And first thing that we must do is create the stem digits, list our stem digits in ascending order from the lowest to the highest. So the lowest value in the stem would be a 4, and then we have a bunch of ages in the 50s, so 5 and 6, and we don't have anything higher than the 60s. So I'm going to list the values here. Now, this problem, I'm going to just give you directions on how to complete it, but I will expect you to complete it on your own. All right. So we will partition our numbers into leaf and stem, and the stem values are 4, 5, and 6. Now we have to write the leaf digits, correct? So we have to go through this one by one again through this list. So the first one is 60. So we go and put a 0 next to 6. And then what's the next value? It's 61. So I'm going to go and put a 1 in the row for 6. Then what do we have? 47. So 47, we have to write 7 for the stem, which has 4. The next one is 58, and then we also have a 54. So I'm going to write 8 and 4. All right, so we have to go through each number one by one and write the leaf value next to the corresponding stem value. All right, and then we will have to also arrange it in order, in increasing order. So the final list is going to look like this. Just a second. All right, the final list is going to look like this. I'm have to erase these values and write it as we have the following numbers for 4: 1, 2, 3, 4, 6, 7, and 9. For 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 8, and they should be, if possible, evenly spaced. 8, 8. There are 3 8s and then 2 9s. All right, and then for 6, it's 0 and 1. All right, so this is our stem and leaf diagram with all the leaf values next to the corresponding stems, and also arranged in increasing order. Right, now since this row for 5 is a long one, we could have broken this into 2 stems per digit. All right, so we could have written this as 4 4, 5 5, and 6 6. All right, and then those would be our stem values, and the leaf values would be like this: 1 2 3 4 for the first stem for 4, and then we would have 6 7 9, 6 7 9. Anything above 4 would go in the second row for 4. All right, and then for 5 it would be 1 2 3 4, and then for the next row for 5 it would be 5 6 7 8 8 8 9 9, and then for 6 it would be 0 and 1. All right, so when we have a long row for one stem, it's better to break it up into 2 rows per stem.